them up and getting used to the concepts. And then later we learned how to actually solve the problems that we had set up in the first part. And so these problems are basically asking you to put everything together and set them up and then solve what you have set up. But once we get it set up, it'll look a lot like the problem I just did on the board a minute ago, where we just have to, we have some function that we want to find the min or max of, and then we're going to graph the constraints, find the corner points, and plug the corner points in, into the objective function to see what the biggest or smallest value was that we got, depending on what the problem's asking for. So, so the real trick here is to set them up. And so you asked me about a couple like ones that are on the activity. So I won't do those ones in particular because that would give away answers to the activity. But what I will do is do something very similar. I can more or less model off of those kinds of problems. So I'm going to make up a situation. So let's say we have the following. I have a bakery that makes 2 types of cookies, let's say. So we have 2 types of cookies. And they'll be sugar cookies and I guess chocolate chip. Okay, and these are going to require some ingredients. So each sugar cookie, or how about just each cookie requires the following. And I'll put this into a nice table. It'll be nice and easy to look at in a table. So we'll have sugar cookies, and we'll have chocolate chip. These guys will be in a table. And there are certain ingredients that each of these requires. So how about this? We're going to need flour. We're going to need, I don't know, salt. And we're going to need, how about chocolate? And let's just say everything is in grams as a unit. We won't worry about converting in this problem. But so everything's in grams, let's say. So I don't know, how about this? Sugar cookie requires, I don't know, 2 grams of flour and 2 grams of salt. And it doesn't require any chocolate to make a sugar cookie. But a chocolate chip cookie will require maybe 3 grams of flour, 1 gram of salt, and maybe 2 grams of chocolate. Yeah. Okay. So here's our setup with ingredients. This is how much each cookie requires. Now, and again, all these numbers are grams. So it's 2 grams of flour, 2 grams of salt, and so forth. So let's say that the bakery has on hand, let's see, how about 500 grams of flour, 300 grams of salt, and how about 200 grams of chocolate. So in a typical one of these problems, you're always going to have the amount that something requires and how much of those things that you have on hand to use. And these kinds of things are going to give us constraints, right? Like I'm going to be limited by the amount of each ingredient that I have. I cannot exceed 500 grams of flour because I only have 500 grams of flour. Okay. Furthermore, let's say that the bakery makes a profit of, how about $1 per sugar cookie and $2 per chocolate chip. How many of each kind should they make to maximize profits? This is a common question we want to be able to answer is, I have some business that's selling some good. I know how much ingredients it takes to produce the goods. I'm limited by a certain amount of ingredients that I have on hand. And I make a certain amount of profit on each good that I sell. how many of the goods should I make to maximize profit? You know, it's a very basic question that you would want to answer. And so that's what we're doing here. I'm gonna write down these numbers so I don't forget them because I'm making this problem up. Okay. Okay, so that's what we're gonna answer here. How do I maximize profit? And so here's our word problem. And to solve this is just a linear programming situation. It's going to involve us finding the objective function, the constraints, and then I'm gonna do like I did in the problem I did a few minutes ago where we graph the constraints, find the corner points, and we plug them into the objective function to find the answer. Okay, so I made this problem up, so I don't know how it's gonna end up doing, but I can work through it and we can see how it goes. Just for completeness sake, I'll go ahead and work through this problem because it's good to know how to find the objective function and the constraints from the information given. So let's look for the objective function first. The objective function has to represent the quantity that I want to either minimize or maximize. So I look for that word, minimize or maximize. I am looking to maximize, as stated in the problem. And the thing that I'm trying to maximize, I guess I should highlight the other word too, is profit. Profit. Profit is what I want to maximize. And so what I need to do is write down a mathematical expression that will somehow represent the profit that I make by selling cookies. And the way to do that is to find variables that represent something here that I don't know, but would like to know. And what do I not know? Well, what's our question asking? It's how many of each kind of cookie should I make to maximize profit? So I don't know how many of each cookie to make, so maybe I should have variables that represent how many of each cookie to make. So maybe I have two types of cookies. I have sugar and chocolate. Maybe I need two variables. I need an X variable that represents the number of sugar cookies, and I need a Y variable that represents the number of chocolate chip cookies. These will be my two variables that I will use. And now I need to use these variables to write down an expression for the profit. And we can do that because I know I'm told in the problem how much money I make from each type of cookie. I make $1 for a sugar cookie, and I make $2 for a chocolate chip cookie. So I'm going to use that information to write down an expression for the profit. And I will write that, I'm running out of room on my board, but I guess I'll just erase up here and write it there. You know, the fact that I make $1 per sugar cookie and $2 per chocolate chip basically tells me that the profit is just going to be X plus 2Y, yeah, in dollars. So the profit is X plus 2Y. So I'm going to write P for the, so I'll write objective function, so we know what's what. P for profit is X plus 2Y because I make $1 per each sugar cookie and I make $2 for each chocolate chip cookie. Okay, so there's my objective function. This is the thing I want to maximize because it represents profit. Now that I have the objective function, the next thing I need are my constraints. So I need to find those. And again, the constraints come from limits on my ingredients. They're limits on the things I have on hand. And so like we're told that I only have 500 grams of flour, there's 300 grams of salt, and 200 grams of chocolate. These are 3 ingredients I have, and I have them each limited. And so what I'm looking at is, what I'm going to have are 3 inequalities coming from these. I'm going to have an inequality that represents my flour. I'm going to have an inequality that represents my salt. And I'm going to have an inequality that represents my chocolate. So I'm going to have 3 constraints at least. There'll be a couple more too, but let's write down these ones. Let's write down a constraint for flour. It takes 2 grams of flour for a sugar cookie, and it takes 3 grams of flour for a chocolate chip. So to represent the total amount of flour that I'm using, I'm going to take 2x plus 3y. And then to finish off this expression, this inequality, I need to compare it to this 500. Well, however much I'm using can't exceed 500 because that's all the flour I have. So 2x plus 3y has to be less than or equal to 500. So this represents the fact that the total amount of flour I use to produce cookies can't exceed 500 because I only have 500 grams of flour on hand. So this represents the flour. Next, I need one to represent my salt. each sugar cookie takes 2 grams of salt. Each chocolate chip cookie takes 1 gram of salt. So the total amount of salt that I use is 2x plus y, and that cannot exceed 300 because that's all the salt I have on hand. So this is my salt inequality, 2x plus y less than or equal to 300. Finally, I have 200 grams of chocolate. It takes 0 grams of chocolate for sugar and 2 grams of chocolate for a chocolate chip. So it looks like I just have y is less than or equal to, 2y is less than or equal to 200. That's my chocolate inequality. And so here are 3 inequalities representing flour, salt, and chocolate usage for my cookies. So that's good. Those are what we'd call the explicit constraints because they're just based off of the information given in the problem explicitly, right? I basically just read off that table and wrote down my constraints. There are also the implicit constraints, which are not given in the problem, but you have to include so that the problem makes sense. And these are the usual x greater than or equal to 0 and y greater than or equal to 0. Because it just doesn't make sense for x or y to be negative because these represent cookies, the number of cookies that I'm making. And it makes no sense to produce a negative number of cookies. So I have to include these or else the problem just won't make sense and I won't be able to get an answer. So these are my 2 implicit constraints that you always have to include. But in all, these 5 give me all of my constraints. Okay. But now from here, this is exactly like the problem I did a few minutes ago. I have a function. I have this system of inequalities. I need to find the maximum of this guy. I'm going to do like I did before. I'm going to graph these, and I'm then going to find the corner points. And I'm going to put the corner points into this function and see what the maximum value is from there. So I will pause for a second and ask if there are any questions or anything about that, what I did so far. And then maybe what I'll ask is, do you guys want to see me then finish this, graph these, go through the process of finishing this? I can do that for completeness sake if you want.
From here, would you just graph those constraints?
Yes, yeah, so it'd be just like the problem I did a few minutes ago. I'd graph these, then you find the corner points, and then you take the corner points and plug them in and look for the max value there.
Okay, no worries.
Okay, so yeah, I think the trickier part with these, once you get good, once you're familiar with that process, the trickier part with these word problems is just how do you set it up. But this is a pretty typical example, I think, as far as setting it up goes. So look for your variables first, then use those variables to write down your objective function. Again, this represents what you want to either minimize or maximize. And then find your constraints. First, look for the ones that are given explicitly in the problem. Again, you're going to look for where you have limited supplies or whatever. Those are going to give you your constraints. And then you have to always include your implicit constraints as well. Let's say that the variables are not negative. So, okay, so if there's not like a big demand, I don't think I will finish this problem. I invite you to try that yourself. It's good practice. But again, it's just like the problem I did before. So I will end this problem. So do you guys have any more questions or requests? I will answer any question. It doesn't even necessarily have to be off the review sheet, just any question at all I can look at. All right, well, if you guys don't want to ask any more questions, that's fine. I don't mind cutting it a little early today. So I'll tell you this then. If you do want to ask any questions like in private or whatever, I'll stick around and you guys can ask questions. But otherwise, I would say you guys are probably free to go. I'll see, yeah. So again, if you want to stick around and ask questions, feel welcome to do that. I'll stick around. Otherwise,